Namaskar. The topic of this lesson is on the ocean waves. Oceanography is an interesting subject in geography. Everybody would like to go to the coastal regions and beaches to enjoy the marine environments. Beaches are always considered as good tourist spots. When we look to the sea from the shore, we can see the dancing ocean waves on the sea surface. If we look carefully, we may notice that the waves are undulations of the sea surface with a height of 1 meter or more. During the course of time, the sea level may also change from one level to another within a day. Waves are never-ending dynamic surfaces created by the action of wind on oceanic water masses. Waves are undulations of the surface layers of the bodies of sea waters. Large bodies of water are almost constantly in motion. Ocean surface are never calm and smooth. They are uneven, irregular, rough and restless. Sea waves are defined as undulations of sea water characterized by unique features. Waves are moving energy patterns. They travel along the interface between the ocean and the atmosphere. The movements of sea water are reflected in the form of waves caused by the action of wind, tides caused by the attraction of moon and the sun, and the ocean currents, and the slow circular movements from the high latitudes to the equator and vice versa, and also the compensatory movements between two basins differing from each other in their density and salinity of water masses. Among these, the waves are caused by the action of wind. Waves are never-ending disturbances seen on the surface of the oceans. The pattern of waves generated by the oceanic masses will never be repeated in the same pattern again. Study of waves is an essential aspect in the subject of oceanography, marine biology, marine geology, fisheries and marine engineering. Hence, in this lesson the following aspects are highlighted: properties of ideal waves, types of ocean waves, processes causing wave formation, breaking of waves, and the tsunamis which are called as the seismic sea waves. Let us see the first part, the properties of ideal waves. When we observe the ocean surface, we can see waves of various sizes moving in various directions, resulting in a complex wave pattern that is constantly changing with reference to time. An idealized progressive wave will have a series of crests and troughs. Crests are the upper parts of the undulations and the troughs are the lower parts of the undulations. The vertical height between a crest and its adjacent trough is known as its wave height. The horizontal distance between two adjacent crests or troughs is known as the wavelength. The ratio between the wave height and the wavelength is known as the wave steepness. The time that elapses during the passing of one wavelength crossing a point is known as the wave period. Wave speed is equal to wavelength divided by wave period. The number of wavelengths that pass a fixed point per unit of time is known as the frequency of waves. The circular orbits followed by the water particles at the surface have a diameter equal to the wave height. The diameters of particle orbits decrease with increased depth until the particle motion associated with the wave ceases at a depth of 1/2 of the wavelength, that is L by 2. Waves are classified into longitudinal, transverse and orbital categories based on their properties. In the case of longitudinal waves, the particles in vibrating motion move back and forth in a direction parallel to the propagation of energy. These waves transmit energy through all states of matter. In transverse waves, the propagation of energy is at right angles to the direction of particle vibration. These waves transmit energy only through solids. A typical example is the rope experiment. If we tie up the one end of a rope at the door knob and the other end is moved up and down with the hand, we may get a series of waves generated from one end to the other. A wave form is set up and progress along the rope. The energy is transmitted from the motion of the hand towards the door knob. If one has to pick out a particular segment of the rope and watch it, the segment would be seen to move up and down at right angles to a line drawn from the door knob to the hand, and it is putting the energy into the rope. This type of waves can transmit energy only through solids. The third type of waves are called as orbital waves. Waves produced on the surface of the ocean have particle movements that are neither longitudinal nor transverse, and these are called as orbital. Since the particles move in circular orbits in these orbital waves at the air-sea interface, these waves are called as orbital waves. The movement of particles along such an interface involves the components of both, since the particles move in circular orbits at the interface between the atmosphere and the oceanic water masses. They are also called as orbital waves or interface waves. Motion of water particles is the underlying principle behind these oceanic waves. Water particles in a sea wave follow the circular orbits at the sea surface. The diameter of such circular orbit is equal to the wavelength near the surface. At the crest, the water particles move in the direction of the energy propagation. The size of the circular orbits flowed by the particles get diminishing with the increasing depth below the sea surface. The water particles in the trough of a wave will move in the opposite direction of the wave. Half of the orbit of the water particles in the trough is at a lower velocity than other half of the orbit in which the particles will follow the crest of the wave. The characteristics of waves differ with reference to deep and shallow water masses. Let us see the differences between deep water waves and shallow water waves. The deep water waves. In deep waters, the water depth is greater than half of the wavelength, that is, d is greater than L by 2. So, deep water waves travel across the ocean in which the depth of water is greater than one half of the wavelength. All wind generated oceanic waves moving across the oceans are all deep ocean waves. Let us see the shallow water waves. These are waves in which water depth d is less than 1/20th of the wavelength, that is, d is less than L by 20, and these are classified as shallow water waves. They are also called as long waves. As waves enter shallow water, they become taller and slow down, eventually breaking on the shore. At a depth half of its wavelength, the rounded waves start to rise and their crest becomes shorter while their troughs become longer and lengthen. Although their period stays the same, the waves slow down and their overall wavelength shortens. The bumps gradually steepen and finally break in the surf zone when depth becomes less than 1.3 times their height. These wind generated waves move into shallow water near the shorelines. Tsunamis and tidal waves are also belonging to a special category of oceanic waves. Tidal waves are generated by the gravitational attraction of sun and the moon. The tsunamis are seismic sea waves generated by the underwater volcanic and seismic activities.